So yeah, let me just explain logarithmic differentiation, how it works. So the first thing you must know is you must know this formulae. The first one says that if you take the natural log of a certain number times another number, this is the same as the natural log of that number, this number, plus the natural log of the other one. And if you're dividing, that's subtraction. Now, the third one is where you have to take the exponent outside the natural logs. So basically here, I'm just gonna give an example where I have y equals x to the power x. So if I say I take the natural log on both sides, this is gonna be x, the natural log of x, because I'm gonna apply this rule when I take the natural log on both sides. Then from then I can then derive and say d over dx of the natural log of y. This will be d over dx of x multiplied by the natural log of x. And then from here this one will be 1 over y dy over dx. And from this we must apply the product rule. Let's say I have y equals f at x times g at x. If I take the natural log here, I'll have the natural log of f of x times g at x. And this means that the natural log of y, this is the natural log of f of x plus the natural log of g at x. Then from this I can then say that if I derive this d over dx of the natural log of y, this is the same as d over dx of the natural log of f of x plus d over dx of the natural log of g at x. From then I can then say that this is 1 over y dy over dx. This will be f prime of x divided by f at x plus g prime of x divided by g at x. Then this means that I can then multiply everything by y. Then I'll have dy over dx. The y will cancel this one. This will be f prime of x multiplied by y divided by f at x plus y times g prime of x divided by g at x. And then from then I can then say that dy over dx, this is the same as f prime of x, but now my y, it's f of x times g at x. Then I have f at x times g at x divided by f at x. Then this will be plus f at x times g at x times g prime of x divided by g at x. Then this means that dy over dx, this is f and f will cancel, g and g will cancel, and then from then I can have f prime of x times g at x plus f at x times g prime of x. So that's just the product rule. If I'm derivating f times g, I can then use this formula to derive this. Apply this here. I'm gonna say this is x prime multiplied by the natural log of x plus x multiplied by the natural log of x prime. So this is gonna be 1 times the natural log of x plus x multiplied by 1 over x. So this is gonna be the natural log of x. This x will cancel this one and you'll be left with 1. So that means dy over dx. If I multiply both sides by y, I'll have this, which I can possibly substitute this back. Then I'll have x to the power x, natural log of x plus 1. So this is logarithmic differentiation. Basically, you just take the natural log on both sides, simplify, then derive. It's that simple. Now let's say I want to derive this one. Notice that if I take the natural log on both sides, I'm gonna have the natural log of something divided by something is the natural log of that something minus the natural log of the denominator. Natural log of the numerator minus the natural log of the denominator. Then from this I can then say that this is the natural log of x multiplied by the cube root of x squared plus 1 minus the natural log of x plus 1 multiplied by the fifth root of x plus 2. Then from then I can then say, now from this side I'm going to apply this rule there. Then I'll have the natural log of x plus the natural log of the cube root of x squared plus 1 minus, I'm going to apply the same rule here. Let me keep the negative like this. Then I'll have the natural log of x plus 1 plus the natural log of the fifth root of x plus 2. So that's what I'm gonna have. Now furthermore, the cube root just means this raised to the power of 1 over 3. Then from then I can then apply this to simplify. Then it will be the natural log of x plus 1 over 3, the natural log of x squared plus 1 minus the natural log of x plus 1. Positive and negative will be negative, and then this just means that this raised to the power 1 over 5. Then I'll have 1 over 5, the natural log of x plus 2. And then that's doing y. Then from then, if I begin to derive, this will be 1 over y dy over dx. The derivative of the x, it's 1 over x plus 1 over 3. The derivative of this will be, you keep the inside stuff as the denominator, then you derive the inside, which is 2x, and you'll have negative. Derive the inside, then divide by them. Then you'll have minus 1 over 5. Then you'll have x plus 2. Then here you'll have derivative of this, it's 1. So that's what you're gonna have. You'll have something like this. And then from then, if we can simplify, that means dy over dx is equals to y into 1 over x plus 2x divided by 3x squared plus 3 minus 1 over x plus 1 minus 1 over 5x plus 10. Then you can substitute y back now. Then if you substitute y back, then that will be the derivative of that. Y is equals to x times the cube root of x squared plus 1 divided by x plus 1 multiplied by the fifth root of x plus 2 into 1 over x plus 2x divided by 3x squared plus 3 minus 1 over x plus 1 minus 1 over 5x plus 10 plus 10. And that's how you can derive this using logarithmic differentiation. That's how you can derive this. Now let's say I have y equals f of x divided by g at x. From this I know that the natural log of y, this is the same as the natural log of f of x minus the natural log of g at x. Then from then I can then derive and say that this is the same as 1 over y, then 1 over y dy over dx. This is f prime of x divided by f at x minus g prime of x multiplied by g at x. And this is the same as dy over dx is equals to y into f prime of x divided by f of x minus g prime of x divided by g at x. That's what you're gonna have. But then y is equals to f at x divided by g at x. Then you'll have something like this: f prime of x divided by f of x minus g prime of x divided by g at x. Now if you try to simplify this, you'll have to cross multiply this in order to simplify this. You're gonna have f of x divided by g at x, then you cross multiply, you'll have f prime of x. This will multiply with this, multiplied by g at x, and this is the negative sign. And then this will multiply with this. You'll have f of x times g prime of x, all divided by this multiply with this. Then you'll have f of x times g at x. Notice that this f of x will cancel this f of x. Then this g at x, since it's at the denominator, it will multiply with the denominator here. So you'll have f prime of x times g at x minus f of x times g prime of x. G at x times g at x, that's g at x square. So this is basically the quotient rule. You can prove the quotient rule using logarithmic differentiation. And so that's just the whole process of this thing. We used it to prove the product rule, and you can also use it to prove the quotient rule. And then from then you can just apply, since you know like the product and quotient rule are correct. Then that's the proof of this. That's the proof.